In this workshop, we'll be looking at how to build AI agents, specifically how to build a multi-collaborator AI agent on AWS with Bedrock, Pinecone, Python, and CDK. What you're currently looking at is the solutions architecture for this application, and it has 4 agents. The first agent is this highlighted is the supervisor or the choreographer, and what it simply does is it gets prompts from the user and directs them to the agents in charge. Now we have 3 remaining agents. The first or one of the agents is called a to-do agent, which simply creates, reads, or deletes items from a Dynamodb table. The reason why I did this agent was just to show you how to enhance your agents with tools and make them carry out tasks or interact with database resources. The next agent is actually a frequently asked agent, and this agent is a RAG. RAG stands for Retrieval Augmented Generation, and it's a method of actually making your LLMs more intelligent and preventing them from hallucinating by connecting data sources or information sources to them. So what happens here is that we have this agent connected to a Bedrock knowledge base, and this knowledge base has an S3 data source, right? And what we'll do is we'll put our frequently asked questions markdown files into that S3 data source. Now the knowledge base picks up or syncs with the S3 data source, gets the markdown files, breaks them down into chunks, little bits of chunks, converts those chunks now to embeddings, and saves them into a Pinecone vector data store for easy retrieval. So now our agent, we can just prompt our agents and ask it questions like, what's a monthly subscription on EduCloud Academy, and it'll easily give that. And the last agent is, this agent was actually born out of necessity because I realized that I had a lot of content on EduCloud Academy and I wasn't really making use of that content the right way. This is the age of AI and there are so many possibilities for playing around with data. So I wanted a scenario where I could easily summarize my workshops, auto-generate questions, evaluate students, search the workshops, translate workshops, and all whatnot. So this is also a RAG, and it's connected to an AWS Bedrock knowledge base. This knowledge base has a data source, S3 data source, and inside this S3 data source, we will put in all our EduCloud content. Now this content will be broken down into chunks. These chunks will be converted into embeddings using an embedding foundation model, which we'll actually look at later. And these embeddings will be saved into a Pinecone vector store. And now we can easily retrieve. So if a user asks a question such as, if a user queries our agent by asking a question such as, please create a to-do item with title, new to-do, description, this is the description of the to-do. And then within that same prompt, they're like, can you please create 10 questions for a particular workshop on EduCloud? I expect my agent, or I expect this agent to query or to orchestrate both of the agents in charge, the to-do agent for creating the to-do items and the content agent for actually querying the content data source or the content knowledge base. So I expect the orchestrator to hit up both of these agents, grab the responses, and return it back to the user. Before we jump right into looking at how or testing the agent, because I've already built this and tested it and it works well, before we look at how that works, let's go and look at an introduction to AI agents. Let's go and look at an introduction to AI agents, because this workshop is strictly for beginners. Even though we'll go way beyond beginner stuff, I still want to touch on just a couple of things. It won't be a lot, just few what are AI agents and stuff like that. I shouldn't talk too much. Let's just get right into it. So again, what are AI agents? These are systems that are capable of carrying out tasks autonomously, such as planning trips, booking flights, creating and making payments, doing market research and interviews, creating to-do items, translating content and stuff like that. And then how do they actually work? So they have an environment, and within that environment they have an environment which they act in, and then they have a set of tools. Take for example the to-do agent we just looked at. It had a set of tools, create to-do, update to-do, delete, and read to-do. And then the environment within which it reacted in, or it works in, was my application. And what are examples of agents? I think you've used a couple of them, but one of the most popular AI agents out there is ChatGPT. Then we have Amazon Q, we have Google Gemini, GitHub Copilot, Replit for generating websites and web apps, both same thing. V0 websites, Lovable, same thing. And how we'll be building these AI agents will specifically use AWS Bedrock. Why? Because it's a managed service that offers a choice of foundation models from multiple providers, or from multiple companies such as Meta, Amazon itself, Stability AI, Anthropic. And you can actually access all of these foundation models through a single API. And it has also gives us the possibility to create secure and responsible AI agents by providing us with guardrails, stuff that we'll be looking at also in this workshop. And back to our main event, let's go now into testing the application and seeing how it works. And then after that, we'll now get into coding the application. Here's how our application works. We have an endpoint, and this endpoint is protected by an API key. Don't worry about even copying it. I'll delete this API key once this tutorial is done, once this workshop is done. So for the endpoint, it's a post endpoint, and it has a body, and that body has a key called query. So now what we want to do is we want to test every agent within our application. And for this query, we're saying, please create a to-do item with title, introduction to to-dos, and description. To-dos are great. Also, do you offer self-service or full service laundry? So now we're trying to hit up two agents, the to-do agent and also the frequently asked question agents. So if I go ahead and click send, I expect the to-do agent to be created, and then I expect a response based on my customer query. It's taking a little bit of time, but it'll send back a response. Great. So it says, I've taken care of both of your requests. Let me summarize the actions and all that. Let's go to the Dynamodb table and just confirm that the agent was, or the items were created properly. So we're in our to-do item agent table, and I'll just refresh. And as you can see, the to-do item was created properly. Let's head over to the AWS console, and let me show you how to run this same request from the agents console on AWS. So I'll copy the request, and I'll go to agents. I'll search for Bedrock. Inside of Bedrock, on the left-hand side menu, we have agents. And then I'll look for the agent supervisor. I'll click on that. And inside the chat box, I'll just paste the request again, and I'll hit run. And as you can see, you're already seeing a show trace link. We'll actually use that to debug our application. Okay, succeeded. But let's look at the trace. First, as you can see on this little graph, we see that it hit the frequently asked questions agent for 9.15 seconds, and then the to-do agent for 6.57 seconds. And that's some really nice detail. So know the amount of time it took to get all of this. And then now it shows us every step it took. So we can expand that and we'll see everything within it, which is really great for observability. Let's go ahead and we have within our content RAG agent, we have a course called Apartment Complex Management System. Let's try to generate a couple of questions for that. And what I'll do here is I'll simply copy this same request, and I'll add it. I'll say please generate 5 questions based on the course department complex management system to test students' understanding. I'll hit enter, and hopefully it doesn't time out. And I think it has done just that. You can go ahead and pause the video and read through if it interests you. But what I want to see is the trace. I want to see if it hit all 3. Yeah, it actually hit all 3 agents. And the multi-agent, the frequently asked questions agent actually took more time than the to-do agent or the content generation agent. And you can, once we're done with this application and we deploy, you can go ahead and test each agent individually and maybe push it to the limit to see what you can find. But from this point forward, I think we should now look at firstly the requirements for building an application like this, and then we now dive into the code and decipher it. Let's get started building our application by making sure we have these requirements installed properly. So we'll be using AWS CDK for infrastructure as code. Python will be the runtime language. We'll have AWS CLI to carry out AWS stuff on our terminal. And then Docker, we'll be using Docker for containerization. And then for foundation model access, we'll be using Anthropic 3.5, Sonnet, and Titan Text Embeddings version 2. So we have to head over to Bedrock and request access to both of these foundation models. And then we'll have to create a Pinecone account. I already have a Pinecone account. If you don't have it, then I'll show you how to create one or create an index, and then grab the API key for that Pinecone account and save it inside the secrets manager for secure and easy retrieval. So the first thing is I want to head all over to Bedrock, and on the left hand side menu I'll scroll to the bottom and click on model access. Here I already have access to the foundation models I need, but if in case you don't have access to those, you can click on available to request and then request model access. Scroll down, you click on next, and you can submit, and within 5 minutes you'll get access to the model. And then secondly, for Pinecone, I'll go to and navigate to pinecone.com or pinecone.io. I'll log in. Continue with Google. I'll actually log in with Google. I already have 2 indexes or indices created, but you can go ahead and create an index for yourself, which should be serverless, and it's free. You don't actually have to pay for anything. And once that's done, you have to scroll on the menu on the left hand side. It's always on the left hand side. You click on API keys, you copy, you create a new API key, you copy the value. Once you've copied the value, let me assume I've copied the value of this API key called RAG. I'll head over to the AWS console. In the search bar, I'll type secrets manager. Also, I already have my secrets saved here, but I'll show you how to save a Pinecone API key. So what I'll do is I'll click on the orange button on the top right hand side called store new secret. Then I'll click on other type of secret, API key, OAuth token, other. And then for the key value pair, for my key, I would say key, API key, and then value. I'll paste the value of my Pinecone API key. And then next, I can give it any name. And finally, I create it. But since I'd already created this before, I will not go ahead to create it again. And finally, what we'll do is we'll now go ahead and create a CDK application with Python as our runtime. I'll open up my terminal. I'll create a folder for my application. So I'll call it Intro to Agents CDK. I have to put make directory, then a cd into this intro agent. And now what I'll do is I'll run CDK init app language Python, and I'll just wait for it to install. And it has already installed. So we'll now have to go open this project in our IDE, and I'll be using PyCharm. You can go ahead and use whatever IDE you're comfortable with. But before we proceed, there's one thing I want to make mention of. Like I said earlier, I've already created this application and deployed it. That's what we tested. So now I'll be copying the code from this application and just pasting in what we've created, and then I'll explain it. So you don't have to worry. All you need to do is listen, and then you type along. And if you cannot type along, all of this code will be on GitHub, and I'll share the link will be on EduCloud Academy, and you can access it at any time. Now I have my application opened up in PyCharm, and the first step is to bring in the required dependencies. So I'll copy these three and I'll paste them here. And auto 3 here is the AWS Python SDK. And then we have the generative AI CDK constructs for L2 constructs for creating generative AI applications using CDK. And then we have our Lambda Python construct as well. With this, I'll just like to open up the terminal and install these dependencies. So I'll run pip install -r requirements text. And you go ahead and install all these dependencies. And while it's installing, I think we should look at the stack. We would have, for this application, we'll have two stacks. We'll have the intro agent CDK stack, which would have all our agents and action groups and Lambda functions within it. And then we'll have the REST API stack, which will contain resources for our REST API, like the REST API itself, API key, the usage plan, and all whatnot. So let's just wait for this to complete installing. And it's done. All right. So right now, we'll focus on a couple of things. I think we'll focus on creating resources for each individual resource we'll be needing in this app. We'll have resources for the Dynamodb table, where we'll save our to-dos. We'll have resources for the secrets, get the secret manager to access the key, the Pinecone key. We'll have resources for agents, aliases, and agent action groups, which is made up of a Lambda function and tools. And in this case, we'll be using an open API schema. Also bring in the dependencies, or the imports rather. Let's paste this here. So from line 22 right up to line 33, we define our Dynamodb table. with a partition key of ID, a removal policy, a billing mode of pay per request. And the name of our Dynamodb table is the to-do item agent table because we'll be saving to-dos within it. And then we define a to-do agent, which has the foundation model as Anthropic Claude 3.5 Sonnet, what we actually requested access to. And then an instruction. So you are a helpful and friendly agent that performs crude L operations on the Dynamodb table. And then every agent, it's always nice to attach an alias to an agent. So we define an agent and we define an agent alias and we attach the agent we created above to it. And then now for the Python function which contains our agent tools, we'd actually have to define that, and it's a Python, and its runtime is Python 3.11. As you can see on line 53, it resides inside a folder which we haven't created yet called Lambda. Let's just go ahead and create a Lambda folder. And then the name of the file is called agent.py. Yep, it's a Python file. And within that Python file, the handler will be called Lambda handler. So let's just define something like that. Path event and context. Return true. Just this. And now we have an agent action group. An agent action group actually has two resources. It has the Lambda function and it has the function tools. But in this case, our function tool will be an API schema. And this API schema is actually an open API schema which has the functionality for our agents. And we'll see how to define those within the action group executor, which is the to-do item function, which we've created above. And then we'll attach this action group to the to-do agent. And since the to-do agent item function will be saving data into Dynamodb, we need to grant it access. So it's not just saving data, we'll be actually saving and reading data to and from the Dynamodb table. So we grant it access, and we also pass in the environment variable, the table name as an environment variable. So with this, let's go ahead and build the to-do. Where is it? Let's go ahead and build the to-do item function. We'll be using AWS Lambda Power Tools utilities such as the tracer, the logger, the Bedrock agent resolver in order to easily create our agent. So the first thing is, before we dive into the Lambda code, let's create a requirements.txt file and bring in AWS Lambda Power Tools, Boto 3 and Pydantic. Then we'll install that too. So I'll cd into Lambda and I'll do pip install -r requirements. You might be wondering why we had to import Pydantic. It's actually requested from the website. Let me go back to the website. AWS Lambda Power Tools for Python. And if we navigate to events, agents for Amazon Bedrock, so they say you need to add Pydantic as a dependency in your preferred tool. But that's why we have this here. And if I go back to my agent, now this Bedrock agent resolver was created, actually took all of the examples from here. Yeah, here, okay, here they showed us an endpoint on how to create a GET request using an endpoint called current time, which actually accesses the current time and returns it back to the user. So here inside my own Lambda function, what I did was I created an endpoint for a post in order to create a to-do. And for the description, I simply said it creates a to-do item in DynamoDB by passing to-do ID, to-do name, to-do description, and status. And then it takes in, well, the description, that was the description, but what I actually gave as the arguments was just the title and the description, which are both strings. And then for the return type was a boolean, which it returns true or false, whether the item was successfully created or not. And simply what I do, what's actually happening here from line 35 right up to 42 is just the simple putting an item into a DynamoDB table. And if you're new to this, I would really encourage you to head over to EduCloud Academy and search for, let's go back, just search for REST. And you have a couple of workshops to help you get started with building REST APIs. So we get the item and save into our DynamoDB table. And then we return true, and if there's an error, we return false. That's just it. And then the next endpoint is the list to do endpoints. Just scanning the table, grabbing all the items and returning them back to the LLM, which returns it back to the user. And then for the put, that's update to do, you can actually pass in the to do ID, the title, description, and status. And it updates all of those and returns if the update process was true or false. And finally, for the delete, we pass in the to-do item or the to-do ID only, which deletes the item from the DynamoDB table. And finally, for our get, we actually pass in the to-do ID, which gets the ID for that particular to-do item, or which gets the item for that ID and returns it back to the user. We have this function or this call on line 61 and line 62, which actually helps us to generate the Open API schema, which we defined or which we access here in our action group. So inside the Lambda folder, if I run Python agent.py, I expect an Open API schema to be, there's an error, to be generated. Let me see. Okay, yeah, I think here, I don't know this, we have to just uncomment this, and then we generate. But I would like to generate inside the Open API.json file. And we have it here, but let's go back and comment this. And what we can do right now is go ahead and deploy our application as it is and test this to-do agent. I think I've brought in all the resources for the to-do agent. Let me just confirm. I apologize, I'm not a genius, so I have to always make sure, and I have to double or triple check and make sure everything works properly. Okay, I think that's it. If you're not able to copy this, remember the GitHub repository has all the code already, so you can just also grab the code and follow along. To do item table. So I'll do a CDK synthesize, which actually converts my CDK code into CloudFormation code. Okay, I'm not in my root folder, so do a CDK synthesize again. And you have to make sure that your Docker container is running as well. Now, our application has been successfully synthesized. Run CDK bootstrap. The application to be bootstrapped to our AWS environment, and then finally we'll do a CDK deploy for the application to be deployed to our AWS account. CDK deploy. This is actually a long process, so I definitely have to cut it short. Yes. Okay, so it has been deployed successfully. The next step is the testing phase where we would navigate to our AWS console. We'll go to Bedrock. On the left-hand side menu, we'll select Agents menu. Oh, I need to sign back in. Alright, so I'm back at my agents, and this is the agent I just deployed. It's called Intro Agent CDK Stack. I'll click on that. And let's just look at a couple of things within this agent. I'll click on Edit in Agent Builder. And what we see here is that we see that it's attached, it has a model, the Claude 3.5 Sonnet, which if we look back at the code, the agent, let's go to our agent on line 39. See that's the foundation model we attached to this agent. So this is it, and then this is the instruction we gave. This is the action group. Click on this action group, we'll see that it has a Lambda function and an Open API schema, the one we generated. I'll go back. Oh, it refreshed the entire thing. Okay. No guardrails yet. It's not a multi-agent collaboration agent yet. So I'll just save and exit. And now I'll have to prepare my agent before I use it. So I'll click on prepare. And what I'll do here is I'll have a conversation with this agent. I'll say, hi, what can you do for me? And I'll wait for a response. You say, hello, I'm here to help you manage your to-do list. Here's what I can do for you. So it gives me a rundown of the tools I had and their functionalities in the agent. And here I'll say, create a to-do item with title, founders, and description. Founders, environment. This is just random stuff. I don't know where I'm getting this from. Hit enter. And it says it has created that. So let's go to our Dynamodb table and just confirm that that has been created, or that to-do item has been created. So I search for to-do. So the to-do item table. And as you can see, this is what we passed in, founders and then founder environment. So now the next thing is I want to just say create 5 to-do items with random titles and descriptions. Let's see if you can do that. Remember, we did not actually give it this functionality, but it's an LLM, and it has reasoning capabilities. It's artificially intelligent, so you should be able to do that. Great, it has created those. Let's go and find out if it's telling the truth. Refresh, and yes, it has. Let's copy the ID of one of them and do an update. Update the to-do item with ID. title, updated title and description, and status completed. Yep. So if we go, it was this. If we refresh it, we'd see that it has converted. Yeah, the status now is completed. You can go ahead and try out the other endpoints or the other functionality. But what I really want to do here is I want to say get a list of to-do items with status completed. Remember, we just for the tool we actually gave our agent was that let it get us a list of to-do items. There was no query where we said get list of to-do items where status is this or where, there was no where clause. We just said get a list of everything, so it's scanned. But now we're asking it to get a list of to-do items where status is this. So now I'm now heavily depending on its artificially intelligent nature to actually reason that okay, it needs to do that even though I did not explicitly define that functionality. So I hope it brings it back and proves me right. Okay, and yes, it has. And we can also go ahead and delete this to do item. Select to do item with ID. And let's find out if it actually deleted it. Yes, it's gone. So you can go ahead and play more with it, but this is all about our to-do agent. And we'll be moving on to the frequently asked question agent. For the frequently asked question agent, here's actually its design. So we have the agent is connected to a knowledge base, and this knowledge base has S3 as its data source, and the knowledge base is now connected to a vector data store. And this knowledge base has a foundation model embedding, and we'll be using Titan. So with all of this information, let's go ahead and bring in the resources for the frequently asked question agent. So we'll head back to the code, and I'll just permit me grab all the resources for this. Okay, copy those. I'll take some stuff off. This is the content not needed. This now alongside this. Okay, from line 74, we've defined a frequently asked question agent. Same thing like the to-do agent we defined, we gave it the same foundation model and then its own instruction. You specialize in answering customer support queries for this application or for our laundry mat service. And then we create an alias and attach the agent to it. And now this agent actually is attached to a knowledge base, and the knowledge base is attached to Pinecone. And remember, we created an index for our Pinecone vector data store. And then we want to bring in resources for the Pinecone vector store, the vector knowledge base, and the S3 data source. Remember, we created the Pinecone index early on in this workshop. So what we'll do is I'll show you how to get this connection string, and then this credential secret ARN, the text field, and metadata field. So let's get the connection string from Pinecone. So I'll go back to Pinecone and then I'll go to database, and this host, that's our connection string. So should copy it. See, it has a dimension of 1024. And we paste here. Please don't share this with anybody. And then for the secrets Amazon resource name, we have to go to our Amazon secret. Mine was called Bedrock Pinecone. And then I can copy this. This is where you copy. I'll delete all of this once I'm done. Then you paste here. And finally, we have the text field as text and the metadata field as metadata. And then we create a new knowledge base called frequently asked question agent knowledge base. We attach the vector Pinecone, the Pinecone vector store to this knowledge base. And then we give it an embeddings with dimensions 1024, like we saw on Pinecone. They have to actually match. This embeddings model, like I said, or like we mentioned earlier, what it does is it converts the chunks of data gotten from the S3 data source. It converts those chunks into vector embeddings, which are then saved into the Pinecone vector store. And then we create an S3 bucket. And finally, we create an S3 data source, attach the bucket and the knowledge base to it. And then for the agent, we attach the knowledge base to that agent. So we can go ahead and do a CDK synthesize. The synthesize step is done. We do the bootstrap step. And finally, we'll do the CDK deploy step. Yes. Great. It has deployed successfully. Let's move over to our AWS console and test. We go to agent. We go to agents. Where is it? Let's see intro agent CDK stack frequently asked. Yes, that's what we need. But right now we cannot really there's nothing we can do with this at this point because we don't have data in our knowledge base yet. There's no data in Pinecone yet. So what we do firstly is to go to S3. Let's close this. I'll search for the frequently asked questions bucket, which is this, and I'll get my laundromat PDF and upload. Once I've successfully uploaded it, I'll go back to the agent, but now I'll go to the knowledge bases menu where I'll see my knowledge base for the frequently asked questions agent. This is it. I'll click on that. This is the data source we created. I'll highlight it and hit sync. And all the data will be like embeddings and saved into the Pinecone data store. You can actually go to the Pinecone vector database and check it out. You'll see it all there. Why is it taking this much time? I don't believe this. Let me refresh. It's taking a lot of time. Sync again. Alright, sync complete. And then I'll go back to my agents. I'll click on my frequently asked questions agent. I can actually see the knowledge base connected to this agent. This agent, remember, it doesn't have an action group, but it has the knowledge base, and this is it. So I can ask it a question from my laundromat. I can say, do you offer free Wi-Fi? Yes, free Wi-Fi is offered for customers, good. And it actually brings up the reference document, which is what we uploaded. So this works well. And the final step, or not the final step, the next agent we'll create is this content agent rack, and it's the same implementation as the frequently asked questions agent rack. Let's go ahead and do that. I'll just bring in the resources as well. The agent and the agent alias. And its instructions. You specialize in answering content generation questions for our workshops. Yes. And the Pinecone agent will bring in the vector store. In the S3 bucket. Connect the agent to its knowledge base. And that's just about it. Same thing. Do a CDK synthesize. That's synthesizing. Again, bootstrap. Finally, deploy. Good, it has been successfully deployed. Again, the first thing is to put all the files inside the S3 data source and then syncing up with our knowledge base before finally testing our agent. So head over to S3 again. Okay, but it has a different S3 table or database rather. Hit refresh. So that's AI learning buckets. And then I have a couple of courses that I would like to add to this. These sample courses, I'll put them in the GitHub repo so you can have them as well. So I'll drag these three and drop them. And the name of we have the apartment complex management system, building a GraphQL API with AWS AppSync and TypeScript, build a GraphQL CrudeL API with AWS SAM. So I'll upload that. And it's done. head over to my knowledge bases, and I have the content agent knowledge base. What I'll do is I'll sync what's inside the S3 data source. Sync complete. I'll go back to agents, and then this is the agent, content generation agent, where I'll ask it a question concerning one of these workshops. I'll choose the build the GraphQL API. Yeah, I'll do that. So I'll say generate or summarize. Is that how it spells summarize? Yeah, summarize the workshop or the course. Build GraphQL API with AWS AppSync, TypeScript, AppSync, and TypeScript. Summarize the course. Yes. Hit enter. Hoping it does that. So exactly. So the course, this is a workshop that teaches participants how to create a fully functional, and I like it because it gives its reference, the document we uploaded to S3. And you can look at the trace, and it shows all the steps it took to arrive at that conclusion. And finally, finally we have to create our supervisor agent and then attach all three of these agents to it. And after that, we'll create an API gateway where we can now use Postman. We don't, because bottom line is we'll not be shipping out our AWS console for our users to test from it. We'll definitely give them an API endpoint, and that API endpoint will be protected by an API key, which they can use now to access our agents. So let's create a supervisor agent. So back to the code. And I'll just copy. So I have a supervisor agent and a foundation model, which is just the same model, and then it has a set of instructions. Now these instructions are really detailed. Say you are a helpful and friendly supervisor agent that routes user queries to the appropriate specialized agents. Analyze the user's query carefully and determine the most suitable agent based on the following rules. 1. Route questions regarding to-do item management to the to-do agent. 2. Route customer support related questions such as troubleshooting or workshop inquiries to the customer support agent. And 3. Route content generation requests like creating summaries, workshop flashcards, or general content related questions to the content generation agent. If the user's query doesn't fit into any specialized category, you may provide general assistance directly. And then for the collaborator agent, we chose supervisor. And finally, we attach all our collaborators. So for the first one is the to-do agent alias, which we created earlier. And then we have the frequently asked questions alias, and then we have the content generation agent alias. And then we create an agent alias of the supervisor agent itself, because we'll be needing that later. And again, we do CDK synthesize. And once it's done synthesizing, the next step is we do CDK bootstrap. And CDK deploy. And great, it has deployed my multi-collaborator agent. And let's just find out. So back to the agents, we'll hit refresh. And as you can see, it has a supervisor agent. And if I click on that and navigate to the bottom, or rather I click on the edit in agent builder, navigate to the bottom and see that it has 3 collaborators. You can click on that. And it has the workshop content generation agent, the customer support agent, and the to-do agent. And you can go ahead and test this supervisor agent. I'll just leave that to you. After you're done testing it, you can come back to the code, because what we'll be creating now is the second stack, which has our REST API resources. I'll just copy the stack, paste here. Add. So it's a REST API stack which takes the agent ID and agent alias as parameters. So we'll have to, this agent ID and agent alias is from the supervisor agent, because we'll be calling the supervisor agent through our REST API endpoint. So we need the ID and its alias in order to do that. So we'll get this and definitely pass it to the Lambda function that's going to invoke the agent. So we'll have a Lambda function from line 28 right up to 37. As Lambda function in a folder, which is the Lambda folder, but we haven't created the Lambda function yet because it's called invoke supervisor agent and handler. It has a timeout of 4 minutes and a memory size of 512 megabytes. And then we give it a rule, since it will be invoking the agent, and the agent, you'll be invoking the agent, and you'll also be invoking the large language model. No, but after you're done testing it, you can come back to the code, because what we'll be creating now is the second stack, which has our REST API resources. I'll just copy the stack, paste here. Add. So it's a REST API stack which takes the agent ID and agent alias as parameters. So we'll have to, this agent ID and agent alias is from the supervisor agent, because we'll be calling the supervisor agent through our REST API endpoint. So we need the ID and its alias in order to do that. So we'll get this and definitely pass it to the Lambda function that's going to invoke the agent. So we'll have a Lambda function from line 28 right up to 37. As Lambda function in a folder, which is the Lambda folder, but we haven't created the Lambda function yet because it's called invoke supervisor agent and handler. It has a timeout of 4 minutes and a memory size of 512 megabytes. Then we give the Lambda function permissions to invoke the agent. We pass in the agent alias and ID as environment variables. And then we define resources for the REST API. Give it a throttling burst and rate limits. We'll create an API key and attach to a usage plan and a stage. And then finally, we create the endpoint resource. And it's a post request, and we attach that to the invoke supervisor lambda function. Now let's bring in the supervisor lambda function. It's in the lambda folder. And as you can see, it actually gets the environment variables we passed in, the agent ID and the agent alias. And all what it simply does is it invokes the agent. When it invokes the agent, it gets the response, it checks if there's a completion key within this response, and then it returns the response back to the API gateway. So finally, we'll deploy this application and then we test it from Postman. CDK synthesize again. And now there are two stacks, so there's a step we missed. We have to bring in both stacks in the app.py file. We have info agent, and then the REST API stack, remember, it takes two arguments, agent ID and agent alias. Okay, so scroll down to the app.py. We have REST API stack for the app, REST API stack. In this REST API stack, we need the agent ID, intro, supervisor agent, the agent ID, then we have agent alias, intro, supervisor agent alias, alias ID. And with this, we can do a CDK synthesize again. And it has finished synthesizing the CDK bootstrap. Finally, since we have two stacks, we have to do CDK deploy all, because I want both stacks to be deployed. Yes. Process error, supervisor agent, invoke agent. Cannot delete an alias that is a collaborator. I'm not deleting anything. Wow, what's happening? Let me see. Is it stuck or is it moving? Let's wait and see. Seems it's still deployed. Yeah. Anyways, yes. Yep, and finally it has successfully deployed. Okay, now that we've finally successfully deployed our application, let's head over to the AWS console again and navigate to API Gateway. Get the most recent deployment, multi-agent, and you see it has a post method and an endpoint attachment called supervisor. What we want is we want to go to API keys. You can check it out because the one for today, multi-agent API key, it has a usage plan. Just copy the API key. We'll move over to Postman, authorizer, X API key, then we add the API key there. And then for the endpoint, we'll copy this endpoint. Um, so it's called supervisor. And then for the body, yeah, we can still run this request now and see uh, if everything works well, then this request has to be successful. It's taken a lot of time. Let's see. Okay, yeah. So I've taken care of both of your requests. Let me summarize the actions and information for you. So yes, our application works perfectly. And we've come to the end of this workshop. And there's just a lot of stuff you can do with multi-agent collaborators. You can build all sorts of agents with it. You can even build e-commerce agents with it, like customer service, like orders, add to cart, get list of orders for a particular day, or maybe make purchases. There's just the possibilities are infinite. The next step we'll take right now is to do a CDK destroy, and we have to clean up all the resources that we created during this workshop. So let's get back to our IDE, and then we do a CDK destroy all. While it's doing that, we have to go to the Pinecone index and delete that as well. Yeah, so I have to delete this Pinecone index. Come back here. Yes, that has been deleted. We have to go to the S3 bucket. No, not the S3. We have to go to the secrets manager and delete the Pinecone secret. disable. We attempted to delete the last time the secret was successful was 1 day ago. Secret manager requires a minimum waiting period. No. Accept this. Great. Unable to delete data from vector store. Yeah, the vector store is gone. We deleted it. Let's delete SDS3 buckets. Hasn't deleted them yet. Delete this. And finally, we delete the bucket itself. See what's happening here. Frequently asked questions. Delete that as well. This is still stuck here. We have to try if the issue persists. I'll delete it manually from CloudFormation. Don't worry about it. Oh, okay. Well, I'll have to wait. But yeah, that's just about it. So once it's done deleting, I believe it would have deleted all the resources we created. And I hope you learned a thing or two. The next workshop will be building generative AI workflows visually using AWS Bedrock flows. And I think it's also a really interesting workshop because we'll be looking at a very interesting use case, and I hope you check it out too. Peace.